Hi, welcome to Virtual CB1A. This is Ma'am Rena, and for this video discussion, we are going to talk about statistical inference. At the beginning of our course, we mentioned that statistics is actually divided into two major parts. So first is the descriptive statistics, or ito yung ang aim nyo lang ay mag-describe ng data through measures of central tendency, usually, tsaka measures of dispersion, and also you can represent your data in forms of graph. So pag ang target mo lang ay magbigay ng general view about the population through measures of central tendency like mean, median, mode, and measures of dispersion like standard deviation, interquartile range, coefficient of variation, and other measures of dispersion, then, nasa descriptive stat lang yung mga methods na gagamitin nyo. But, if your target is to make inferences or mag-prove ng mga assumption about a certain population, ito naman yung target natin, inferential statistics na branch, yung panggagalingan ng mga treatments na gagamitin. Okay? Okay. So for statistical inference, it is defined as the use of data to make judgments or decisions about the population. So dito, magja-generalize ka ng characteristic ng population through a single value rin. Just like descriptive. But this time, meron tayong additional steps na gagamitin. So more than just estimation na ginagamit na natin sa descriptive, nag-estimate tayo ng mean, median, mode, gagamit din tayo ng process of hypothesis testing. So what do we mean by estimation? Estimation is concerned with finding a single value or a range of values which is likely the value of the parameter of interest. When we say parameter, this is the true value from the population. Now, ito yung madalas na pinanggagalingan ng confusion. Minsan, we confuse estimator as an estimate and estimate as an estimator. But actually, magkaiba sila. Pag sinabi mo estimator, formula yan o yung ginagamit mo sa paghahanap ng estimate. Okay? So, estimator is a formula for finding a value of parameter based on a random sample of n drawn from the population under study. For example, the mean o kaya proportion. So, parang fresh sa inyo tong symbol na to. This is p hat. It is called p hat, but this is actually the notation that we're going to use for the proportion. Ito, familiar na naman kayo dito eh. This is the average mean or the average or mean. Kapag population mean, ito yung symbol. Pag x na may bar sa taas, sample mean. So, estimate. The estimate is the computed value of the estimator. Okay? Okay. Now, may mga tinatawag tayong point estimate. Ano yung point estimate? It provides the best guess as to what is the value of the population parameter, and you have to take note of this. It is not 100% accurate. So, minsan kasi, nagkakaroon tayo ng existence of outliers, right? So, na-discuss natin ang outliers before, mga extremely low or extremely high numbers. Marami kang pwedeng makuhang point estimate. Paano? Kasi pwede ka magkaroon ng maraming sampling distribution. For example, ang target natin ay population ng college students sa PSBC. And then you are going to randomly select 100 samples. Out of that 100 sample, pwede ka makakuha ng point estimate. Pwede ka makakuha ng mean, median, or mode, di ba? But what if nag-ulit ka ng research, may nakita kang mali, tapos nag-random sample ka ulit ng 100, but that second set of random samples is not the same as the first set of random samples. Kasi, hindi mo na mahanap yung mga dati mong naging respondents. Possibly, you will get another point estimate. What if On your second trial, nagkaroon ka ng mga outliers na hindi present nung first trial mo. There is a likelihood na between the two set of samples, merong mas accurate at merong mas malayo sa or mas mababa ang accuracy. Imagine if you are going to repeat it over and over again. You are going to take 100 respondents ng paulit-ulit. You will always get a different point estimate. Or there is a high likelihood that you will get a different point estimate for every trial. And some of them will be more accurate than others. Why? Kasi may tendency na magkaroon tayo ng mga outliers na hindi present dun sa ibang set of samples. Okay? Now, it will vary from one sample to the next. Ayan, kasasabi ko lang kanina. And its standard error will provide an idea of how far away it would tend to vary from the parameter value on average. So, ito hindi na natin to na-mention before. Okay? So, later on, i-explain natin yung standard error kasi new definition to para sa inyo eh. Okay. So, kanina, nag-discuss tayo ng point estimate. Ngayon naman, we are going to discuss confidence interval estimate. Okay. So, the general format is given by point estimate plus minus a few standard errors and the few or number of standard errors away from the point estimate depends on how much confidence will be attached to it. There is a video lecture about confidence interval. I will send it to you later. But at the moment, focus muna tayo dito sa general na format. It is point estimate plus minus a few standard errors. So kapag confidence interval, you are actually looking for a value. Halimbawa, hinahanap mo yung population mean through your point estimate sample mean. Instead of relying on just one single value, which is your point estimate here, pwede kang gumawa ng range. Yung range mo, it is plus minus a few standard errors away from your point estimate. So, dito, mas malapit sa reality yung makukuha mong range. You can assume that the true characteristic of the whole population is within this interval or nasa loob siya nitong range na to. For example, you are looking for the average grade in mathematics of senior high school students. And your point estimate was given by the value 88. And then, nag-compute ka ng standard error. From your standard error, you found out that it is 5 points. Then, from your point estimate here, pwede mong isuggest that this confidence interval, 88 minus 5, which is 83 to 88 plus 5, 93. Ayan. So, the true characteristic of your whole population or the true average grade of the senior high school students in mathematics is from 93 to 83 or from 83 to 93. Inside lang siya no interval na yan. Anything that is below 83 and above 93 will be very unlikely. So, malabo na ang standard grade or ang standard mean grade ng mga senior high school students ay, for example, 80. So, mababa na yung likelihood nito. Okay? Okay. Now, let's talk about confidence level. So, si confidence level, lagi na natin itong gagamitin sa inferential statistics. So, it reflects how confident we are in the procedure. The common confidence levels are 90% given by alpha 0.10, 95 given by alpha 0.05, and 99 given by the alpha 0.01. Ayan. Each interval either contains the population parameter or it doesn't. And the percentage of the time we expect the procedure to produce an interval that does contain the parameter. Ayan nga, the percentage of the time. Kaya naka-percentage sila. Okay? Okay. Now let's talk about hypothesis testing. It uses data from a sample to judge whether or not a statement about a population hypothesis is reasonable or not. Lagi tayo ng mga steps in hypothesis testing. First, you have to formulate your null and alternative hypothesis. Na-discuss nyo na to before nung grade 11 kayo. Verify necessary data conditions and if met, summarize the data into an appropriate test statistics. Ito yung medyo mahirap gawin, pero simple lang talaga siya. Nakalagay dito, verify necessary data conditions. Before ka makapag-decide kung ano yung tamang test statistic, dapat i-review mo muna yung variables mo. And then, dapat marunong ka mag-classify kung ano yung type ng variable mo. Qualitative ba? Quantitative? Next, you have to know how to identify the level or scale of measurement. I believe marunong na naman kayo nun. Marunong kayo mag-classify kung nominal, ordinal, ratio, or interval. And also, data condition, ano ba yung target nung problem nyo? Ano yung target nung hina-hypothesize nyo? Siguro to give you a good view of what I am talking about, may papakita akong chart. Wait lang. Okay, this is what I am talking about. So, in choosing your test statistics, ito yung mga green na box, ito yung mga test statistics under inferential statistics. Isang part pa lang to, parametric tests pa lang to. Ito yung nag-a-assume na normal yung population nyo. Marami pa to. May non-parametric tests pa, pero hindi ko na siya sinama since these are the most frequently used test statistics and traditionally we often assume that the population is normal. Okay. Kung hindi ka marunong mag-classify ng data mo, hindi ka marunong mag-analyze, tapos na kayo dun. Hindi nyo na mahahanap kung ano yung appropriate na test statistics. And also, there are certain conditions. So, paano kung nagko-compare ka ng means? Dalawang means. Paired sample ba or independent sample? May data ka ba ng population standard deviation or wala? Ilan yung number of samples mo? So, these are just some of the questions that you have to answer in deciding the appropriate test statistic for your study. Okay. Next na step. Pag marunong ka nang mag-identify ng constraints nung problem mo, mag-specify ka na ng level of significance. So, how much error do you think you can allow in your study? Or are you willing to risk para dun sa study mo? If you want it to be really reflective of the true situation ng population, syempre, tataasan mo yung level of significance mo. Pwede kang mag 99%. But if you, ang downside ng pagtataas ng level of significance, you will have to include more samples. But if you allow, say for example, 90% level of significance, medyo mas malaki yung chances niya of committing error. But it will give you sa pag-choose ng sample, it will allow you to select a smaller sample at saka it will give you a higher probability of rejecting the null hypothesis. Okay? Kapag ka tinataasan mo tong level of significance mo, mas mahirap i-reject si null hypothesis. Pero kapag ka binababaan mo yan, most likely, mare-reject mo si null hypothesis. Yun nga lang, prone ka sa error. Okay? Okay. Now, determine the critical region of your test. Ito, didiscuss natin to mamaya. Kung tandaan nyo pa yung diniscuss natin before, nung grade 11 kayo, na mga ganyan, yung mga curves, normal curves, bell curve, mga distribution natin sa Z, standard. Babalikan natin yan ulit for determining the critical region of your test. But, during discussion, i-apply natin to, yung pag-shade ng region. Pero pag magko-compute na kayo, mas preferred ko kung gagamit na lang kayo ng mga software or applications like Excel, Google Sheet, tsaka yung mga add-ins natin like data analysis. Kung may access kayo sa Megastat o kaya JustP, SPSS, better. Yung mga statistical software and packages natin. Yung iba free download. Mamaya, papakita ko sa inyo ng sample ng built-in na sa Excel. So, number 5, assuming the null hypothesis is true, compute the value of the test statistic. So, na-identify mo na yung mga conditions and constraints ng problem mo, mag-compute ka na kasi alam mo na yung estimator mo eh. Para malaman mo kung ano yung itetest mo na value ng estimate. Next, decide whether or not the result is statistically significant based on the value of the test statistic. So we have two methods. One is through the value of the statistic method, or test statistic. Gagamit kayo doon ng mga table. Pero may isa pang method, yung p-value method, which is more convenient kasi hindi na kayo gagamit ng table eh. Sa p-value method, ang titingnan nyo na lang ay probability. And then, i-compare nyo na lang siya dun sa standard error. Okay? Okay. Next, let's go to number 7. Report the conclusion in the context of the situation. Now, how do we formulate hypothesis? So, many questions in research can be expressed as which of two statements might be correct about a population. So, laging contradicting yung mga hypothesis natin. For every problem, meron kang dalawang statements. The first one is called the null hypothesis and the other one is called the alternative hypothesis. In symbols, we use HO for null and H sub A for alternative. Dun sa ibang books, this is H sub O and H sub 1. But, recently, mas preferred itong H sub A. Bihira na yung gumagamit ng H sub 1. Okay, the null hypothesis H sub O. Ang kiniklaim nito, laging no effect, no difference, nothing has changed, or nothing is happening, or nothing is, or no relationship exists between variables. Basta si null hypothesis, lagi niyang sinasabi, no. Okay? So, laging walang difference or laging no effect. It is usually referred to as the status quo. Now, when it comes to alternative hypothesis, H sub A, statement naman to of yan. Kabaligtaran naman siya ng HO. Kung laging no si HO, si HA naman ay laging yes. Yes, may relationship. Yes, may difference. Yes, something has changed. Yes, something is happening. Okay? Usually, the researcher hopes the data will be strong enough to reject the null hypothesis and support the new theory in the alternative hypothesis. So, ang target ng mga researches always ay manalify ito, null hypothesis. So, ma-reject siya. Ang target natin ay matanggap ito. Pero hindi yun ang laging case ha. Minsan, wala kang magagawa sa computation mo lumabas, hindi mo talaga mare-reject si HO. And that's okay. You just have to support your findings. So, let's start with this problem. Form the null and alternative hypothesis in the following situation. A pharmaceutical company wants to be able to claim that for its new medication, the proportion of patients who experience side effects is less than 20%. So, meron tayong iba't ibang ways ng pagsusulat ng null and alternative hypothesis. Pwede siyang through symbol. Pwede rin naman na pa-words or through sentences. So, dito, mag-create daw tayo ng HO at HA. Gamitin natin yung parehas na method. Una, through symbol muna. Take note, this is proportion. And as I've mentioned earlier, it is denoted by P hat. So, the proportion is 20%. Ang sinasabi ni null hypothesis, laging no difference or laging equal lang. So, ang clue nyo, kapag nag-formulate kayo ng null hypothesis, ang lagi niyang kiniklaim, equal lang. So, the proportion is equal to 20%. Contrary to the alternative hypothesis, which states that the side effects is less than 20%. So, yung kiniklaim nung research, yun yung HA, as we mentioned earlier dito. Ayan. They hope the data will be strong enough to reject the null hypothesis and support the new theory in the alternative hypothesis. So, ang theory is that the proportion of patients who experience side effects is less than 20%. So, dito siya sa alternative hypothesis. Remember, HO is always equal. Kasi kapag ka-equal, no difference, no relationship, no change, nothing is happening yon. Okay? So, dito, in sentences, pwede natin siyang sabihin as the proportion of patients who experience side effects is 20%. Now, dito naman sa kabila, ito na yung bagong theory natin. Oops. Dahil sobrang mahaba siya, kokopyahin ko na lang. Imbis na is, magiging ano na to, is less than 20%. Okay? So, ganito mo siya i-represent in forms of sentences. Clear? I hope it is clear. Ayan, dito naman tayo sa kabila. A researcher thinks that if expectant mothers use vitamin pills, the birth weight of their babies will increase. The average birth weight of the population of babies is 8.6 pounds. So, may keyword tayo dito. Maghanap tayo ng keyword. Ang sabi niya, increase. Kung ang average birth weight ng babies ay 8.6 pounds, ang bagong theory natin, pag nag-vitamins ang mothers, mas magiging mataas sa average weight na 8.6 pounds yung weight ng babies. So, let's write here H sub O. Take note, this is average birth weight. So, ang ilalagay natin ay teka. May mali ako. Kasi, hindi nga pala dapat ito yung gagamitin natin. Kasi, naka-mention dito population. So, dapat ito. So, population, average birth weight is 8.6 pounds. For H sub A, the average birth weight of the population is greater than 8.6. Now, paano natin ito isusulat? Ang gagawin natin, the average weight of babies is 8.6 pounds. Or pwede ka rin maging creative sa context ng problem which is more appropriate. Pwede mo sabihin na the birth weight of babies whose mothers took vitamin pills did not increase from 8.6 pounds. Ayan. So ito, mas kaya niyang i-reflect yung situation ng problem. So the birth weight of babies whose mothers took vitamin pills did not increase from 8.6. So wala siyang significant na difference. Ano yung counterpart nito dito sa HA? So copy natin yung sentence natin dito. So, the birth weight of babies whose mothers took pills did not increase from 8.6 pounds. Dito, nagkaroon na ng increase. So, increased from 8.6 pounds. You also have another option. Pwede mo ring sabihin na is greater than 8.6 pounds. Okay? Just analyze your word problem and then i-construct nyo kung ano yung scenario in sentences in the form of hypothesis. And you're good to go. Okay. Notes. When the alternative hypothesis specifies a single direction, the test is called one-sided or one-tailed test. Dito, meron tayong word na less than. Dito sa kabila, meron tayong word na increase. So, one-sided siya, parehas. Kasi yung isa, ang pupuntahan lang niyang direction ay lahat ng mababa sa 20%. So, lagi siyang to the left. Wherein dito naman sa kabila, increase, to the right naman siya, greater than 8.6. So, if you have inequalities, less than, and greater than, it is one-sided or one-tailed test. Ayan. Greater than or less than. When the alternative hypothesis includes values in both directions from a specific standard test, it is called a two-sided or two-tailed test. So, ito naman yung para sa mga not equal. Later on, magbibigay tayo ng example ng two-tailed test. Kasi yung dalawang example ko dito ng null and alternative ay parehas one-sided. I didn't notice that when I was constructing this presentation. Sorry. So, next, a generic null hypothesis could be expressed as H sub O, population parameter, is equal to the null value. Where the null value is the specific number, the parameter is equal to if the null hypothesis is true. Ano yung sinasabi dito sa generic null hypothesis? Ito yon. Ito yung mga generic na null hypothesis. Yung nakasymbol lang. Okay? Okay. Format natin ay point estimate or population estimate at saka yung null value. Ayan, null value. Population parameter and null value. Okay. Sabi ko kanina, prone sa error kapag ka mababa ang level of significance, right? So, magkakaroon ka ng error sa hypothesis testing pag mali yung decision mo. Meron tayong tinatawag na type 1 error saka type 2 error. So, type 1 error, pag nireject mo yung HO, when you shouldn't. Totoo pala si HO, totoo pala na no change, no difference, no relationship. Pero nireject mo siya. So, you are committing type 1 error. And then, you are committing type 2 error kapag ka hindi mo nireject si null hypothesis, mali siya. Ka-reject-reject siya. So, mas maganda na aralin natin tong table na to so you can establish the relationship. So, true state of the population, HO is true. No difference, no change. And what you did is you rejected HO. So, you're committing type 1 error. But, if HO is true, and you did not reject HO, you accepted HO, then you are committing right decision or you are making a correct decision about the population. Okay. Dito naman tayo sa kabila. HO is false. Mali siya. May relationship. May difference. At nireject mo siya. You are making a correct decision. But if HO is false, tapos inaccept mo siya, that is type 2 error. Okay? Okay. Now, what is the likelihood of errors? So, this is represented by alpha or type 1 error. Usually, ito lang yung tinetest natin. Hindi tayo nagbe-beta, hindi tayo nagta-type 2 error testing. Hindi natin mini-measure yung likelihood of error for beta. Type 1 error, alpha, reject HO when HO is true. This is equal to the level of significance. So, if your level of significance is 99%, your alpha or your probability of committing error is just 0.01 or 1%. So, kung 99% ang level of significance mo, you allow 1% room for error in your study. If you are setting your level of significance to 90%, then you are allowing a larger probability of committing an error, which is 10%. P here means probability. Okay? Probability of making type 1 error. As I've said earlier, si beta, hindi natin siyang usually pinapansin. So, P is the type 2 error. P is failing to reject HO when HO is false. And P, it is the probability of accepting HO when HA is true. So, wala siyang measure dito. Unlike si alpha. Sa mga tables pati, sa mga table ng statistics, ang madalas yung makikita ay si alpha. Likelihood of error. Now, ito yung sinasabi ko kanina, yung mga critical regions. Area bounded by a value which can be thought of as a threshold, say C. And this C is usually derived from a table of values in statistics. Depende dun sa ginagamit mong test statistics. Minsan magkakaroon ka ng use ng T-table. Sometimes you are going to make use of the Z-table. Other times you are going to perform F-test. So, F-table naman yung gagamitin mo. There are a lot of different test statistics that exist in inferential statistics. So, iba't ibang table din yung gagamitin mo. If you are looking for the threshold C. Hindi kasi tayo naka-p-value pa. Test statistic type yung magiging magiging basis natin for accepting and rejecting the hypothesis. So dito, for example, HO, the proportion is equal to 0.20. Ito yung una nating example, and HA is less than 0.20. So, ang titingnan mo ay yun nasa labas ng threshold mo. So, since less than siya, to the left, kung ito yung threshold mo, kung ito yung nakuha mo na value sa T-table, at titingnan mo yung nasa labas niya, pakaliwa, isang tail lang. As you can see here, kapag meron tayong normal distribution, meron tayong dalawang tail, isang left tail at isang right tail. Siyempre, ito yung left na tail. Tapos ito naman yung right na tail. So dito, if we are checking for the proportion na less than 0.20, ang titingnan mo ay yung to the left of your test value C. Imbis na threshold, tawagin natin siya, sige, test value. Ito yung galing sa table. Okay? Okay. Now, if you are testing if the proportion is greater than the theoretical value, 0.20, Then, ito naman yung titingnan mo, yung nasa labas. Ito yung threshold mo, yung C. Ang i-check mo, yung to the right. Okay? Okay. I hope I was able to make that clear. This time, dito naman tayo sa pangatlong graph. So, ang example natin ay may dalawang shaded na region and then hatirin yung error natin by 2. So, alpha over 2 siya. So, mas maliit yung area na makakukuha niya for the two tails. This happens when you have a problem na katulad nito. Palakihin natin medyo hindi kita eh. As you can see here, it is not equal. So, wala siyang direction. Hindi mo i-measure kung less than siya or greater than siya. Ang mahalaga, hindi siya equal sa 0.20. So, ang titingnan mo ay yung both tails ng iyong curve. Okay. Or, dun sa ibang mga test statistics, it is given by positive, negative. Okay? Okay. Pag nagsasolve na tayo mamaya, hopefully mas maging malinaw to. But please, pakitandaan na yung mga graphs na ipinapakita ko. Now, let's talk about test statistic. Naka-general to pero complicated yung mga nito, yung mga formula nito. May mga makikita kayong ganyan, summation, may mga makikita kayong symbol na I, N, X, mga ganyan. But in general, this is the idea. A test statistic is a standardized statistic that measures the distance between the observed statistic and the null value in the standard error units. So, it is observed statistic minus null value over standard error or null. Uy, tapos na pala tayo. Okay. So, ikakat ko na muna siya dito sa discussion natin ng test statistic kasi I think the next part will be the one na magpa-practice na tayo kung ano-ano yung iba't ibang test statistic na pwede natin gamitin at saka magko-compute na rin tayo. So, thank you very much for listening and please wait for the next video. Thank you! See you soon!